Hello and welcome to Nkumat Online Academy. In this lesson, we want to look at the last quiz given on probability. So we want to solve it together in this lesson. A copy of a screenshot of the questions is here. Number one question says, a fake coin is tossed twice. Find the probability of getting two heads. The probability that two heads appear. The probability that two tails appear. Number two, that is B. And C, probability that at least one tail appears. The fake coin is tossed twice. So what do? We use our probability table. We draw probability table for it. Head and tail. The numbers or the things you are going to write for the first one and the second one, it depends on the number of sides that the coin or die or anything you are working with has. For a coin has two sides, and the two sides are numbered head and tail. So you put head and tail here, you draw this line, vertical line, then you come up for the second coin. This is the first coin. The second one, you write it on top of this head and tail. Then you draw another line. This is vertical, this is horizontal. Now you join this first one and this first one, and that gives us, you write it under this, it becomes head. The first one is head and the second one is also head. So we have head. Now you join this one also and the second one, that is, you join this one and this one. So that will give us head and tail, head, tail, HT. Now you come to the second row, you join this one with the first one here, that will give us T and H, that is tail and head, T, H. Now you join this one again with this one, and that will give us tail, 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 tail. This is our sample space. So we visit the question again. The question says A, the probability that two heads appear. So which of these has two H, that is two heads? This one has one head, that is one head. This one has one head. This one does not even have any head at all. It is only this one that has two heads, that is HH. So this is the events in question, the one we are working with. It is only one. Why the sample space we have 4? 1, 1, 2, 3, 4. So the probability of getting two heads, that is HH, is 1/4. That is 1 out of the sample space. There is only one HH, and the total sample space is 4. So we have A. For A, the probability of getting HH is equal to total number of HH is 1 over total number of sample space is total number of events in the sample space is 4. 1, 2, 3, 4. So 1/4. This is the answer to number 1. Then question number 2, number 1b, the probability that two tails appear. Two tails appear. Back to the probability table. Two tails. This one has one tail. This one has one tail. This one does not have any tail at all. This one is the only one with two tails. That is 2t, tt. So we have 1 over the total number of events, which is 4. So again, tt is equal to 1 over 4. B, probability of tt, which is 2 tail, is equal to 1 over 4. Then for C, the question is find the probability that at least one tail appears. That is the one that contains at least one tail. At least one tail. This one contains one tail. This one contains one tail. This contains one tail. It say at least, which means that from 1 or 2 or 3 or as many as it can contain. So once we find at least one tail in it, we will count it. So this one has 1, this one has 1, and this one has 2. So this one that has 2 is also among. So the probability of at least one tail is equal to 3. Total number of events with one tail, with at least one tail, is 3. 1, 2, 3. So this is the only one that does not contain tail at all. And the sample space still remains 4. So we have that probability of at least one tail, at least one t, is equal to 3 over 4. This is the answer. So we have solved question number 1. Then question number 2. Question number 2, it says, if 2 dice are rolled, what is the probability that the sum of the 2 numbers shown is 7? Sum of the 2 numbers shown is 7. Sum of 2 numbers shown is even. Sum of 2 numbers shown is greater than 7. Okay. Now, we go back to the solution. What we do is to draw our probability table for this. We draw the probability table. To draw it, this is for a die. For us to gauge for dice, we label the number of sides. For the first one, it has 6 sides, numbered 1, 2, 3, 4 to 6. So 1, 2, 3, 4. Let me make it smaller. 1, 2, 3, 4, 5, 6. Then for the second one, we have 1, 2, 3, 4, 5, 6. Now we join them. We join the first one in the vertical line with all the numbers in the horizontal. That is, we take this one and join it with this, join it with this, join it with this, join it with this and this. Then we now take the second one, join it again to the end, take the third one, join it again to the end, take the fourth one, join it again to the end until we finish the whole numbers. Now that becomes, for here we have 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6. Let me clean this and make it look more tidy. Let me draw lines to separate them. Just to make it look more tidy. Okay. Now under for 1 we put it here. This one 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6 4 1 4 2 4 3 4 4 4 5 4 6 5 1 5 2 5 3 5 5 4 5 5 5 6 6 1 6 2 6 3 6 4 6 5 6 6. Okay, so we now have all the sample space. Now the question, in question number 2a, question number 2a, we are told to find the sum of two numbers, that the probability that the sum of two numbers shown is 7. So what we do now is that we come to the table we have drawn. We come to our table, we look for the two numbers that when we join them, when we add, sum means addition. When we add the two numbers, it is going to give us 7. That is the equation. So all these ones here, we'll be looking at them one by one to know the ones that when we join them, it will give us 7. Let's start with the first row. 1 plus 1 will not give us 7. 1 plus 2 will not give us 7. 1 plus 3 will not give us 7. 1 plus 4 will not give us 7. 1 plus 5 will not give us 7. 1 plus 6 will give us 7. So we mark it. Okay, so this one, we mark it number 1. 2 plus 1 will not give us 7. 2 plus 2 will not give us 7. 2 plus 3 will not give us 7. 2 plus 4 will not give us 7. 2 plus 5 will give us 7. So we mark it. 3 plus 1 will not give us 7. 3 plus 2 will not give us 7. 3 plus 3 will not give us 7. 3 plus 4 will give us 7. So we mark it. Fourth row, 4 plus 1 will not give us 7. 4 plus 2 will not give us 7. 4 plus 3 will give us 7. So we mark it. 4 plus 4 will not give us 7. 4 plus 5 will not give us 7. 4 plus 6 will not give us 7. The other row, 5 plus 1 will not give us 7. 5 plus 2 will give us 7. We mark it. 5 plus 3 will not give us 7. 5 plus 4 will not give us 7. 5 plus 5 will not give us 7. And 5 plus 6 will not give us 7. The last row, 6 plus 1 will give us 7. So we mark it. 6 plus 2 will not give us 7. 6 plus 3 will not give us 7. 6 plus 4 will not give us 7. 6 plus 5 will not give us 7. And 6 plus 6 will not give us 7. So these ones marked are the ones that will give us 7 when we add two of them. So we count the total number of the ones that will give us 7. That is the total number of the ones I've marked here. They are 1, 2, 3, 4, 5, 6. So we have 6. Now we count the total number of samples or events in this sample space. If we count everything, it's going to be 6 times 6. That is this 6 here and times this 6. So it's going to be 6 times 6, which is 36. If you count all these things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. If you count everything, it's going to give us 36. So we now say answer 2a is equal to A is probability of getting a sum of 7, which is equal to 6 over 36. 6 over 36. Okay, we can also break this. If we divide again, we get 2, we get 3, we get 18. Yes. Okay, so we can still continue dividing until we get to the smallest fraction. Okay, so this is it. Now we go to question number 2 there. The question number 2 says the probability of getting sum of two numbers shown is even. Now we go to the table. Sum of two numbers shown is even. That is two numbers that when we join them, it will give us even number. Well, the two numbers that when we join them, it will give us an even number. That is number that can be divided by 2. We start from the first row. 1 plus 1. 1 plus 1 will give us 2. And 2 is an even number, so we mark it. 1 plus 2 will not give us even number. 1 plus 3 will give us 4. And 4 is an even number, so we mark it. 1 plus 5 is not an even number. 1 plus 5. 1 plus 4 is not an even number. 1 plus 5 is an even number. 1 plus 6 is not an even number. Then row 2. 2 plus 1 is not an even number. 2 plus 2 is 4, even number. 2 plus 3 is not an even number. 2 plus 4 is an even number. We mark it. Then 2 plus 5 is not an even number. 2 plus 6 is an even number. 3 plus 1 is an even number, 4. 3 plus 2 is not, 3 plus 3 is 6 even, 3 plus 4 is not, 3 plus 5 is even, 3 plus 6 is not, 4 plus 1 is not, 4 plus 2 is, 4 plus 3 it is not, 4 plus 4 is even, 4 plus 5 is not, 4 plus 6 is even number, 5 plus 1 is even number, 5 plus 2 is not, 4, 5 plus 5 plus 5 plus 2 is not, 5 plus 3 is even, that is 8, 5 plus 4 is not, 5 plus 5 is, 5 plus 6 is not, 6 plus 1 is not, 6 plus 2 is 8, that is even, 6 plus 3 is not, 6 plus 4 is 10, even number, 6 plus 5 is not, 6 plus 6 is even number. So we count the total numbers we have marked, that is the total even numbers. In the first row we have 1, 2, 3, second row 1, 2, 3, third row 1, 2, 3, fourth row 1, 2, 3, fourth row 1, 2, 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 over the sample space is 36. 18 over 36. So B is equal to probability of even number is equal to 18 over 36. So that is how to solve this one. Then the next question, the next one that says the probability of getting sum of two numbers shown is greater than 9. Two numbers that when we join two of them, it is going to give us greater than, something that's greater than 9. So we go back to the table. Let me clear this. Okay. Now here, which ones that when we join them, it will give us a number that is greater than 9. In the first row, the highest one is 1 plus 6, and 1 plus 6 is not greater than 9. So there's nothing greater than 9 in the first row. In the second row, the highest one is 2 plus 6, and 2 plus 6 is 8. So there's nothing here. In the third row, the highest one is 3 plus 6. 3 plus 6 is 9, but we are looking for something that is greater than 9. So this one is not included. Nothing is greater than 9 in the third row. 9 is not included. Is any number that is greater than 9. That is from 10, 11, 12 and above. So in the fourth row, we start looking for numbers greater than 9 in the fourth row. 4 plus 4 is not greater than 9. 4 plus 5 is 9. It is not. Then 4 plus 6 is 10. So we have 1 now. So we mark it. This one, 4 plus 6 is 10. So it's greater than 9. Then we come to the fifth row. 5 plus 3 is not. 5 plus 4 is not. 5 plus 5 is 10. We mark it. And 5 plus 6 is 11, is more than 9. Then the sixth row, 6 plus 3, 6 plus 1, not up to 9. 6 plus 2, not up to 9. 6 plus 3 is 9. And we are looking for something greater than 9. so this one is not included. Then 6 plus 4 is 10, so it is included. 6 plus 5, 11 included. 6 plus 6 is 12 included. Okay, so we have all of them now. So we check the total numbers we have marked. It is 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So we have 6 numbers or 6 events that are greater than 9 in this sample space. So our probability for numbers C, probability for number greater than 9 is equal to 6 over 36, which you can now simplify further to get to the smallest fraction. If there's anything that can divide 6 and divide 36, we divide it. It will actually give us 1 over 6. 1 over 6 when we simplify it further. 6 divided by 6, even this one will give us 1 over 6. 1 over 6. Okay. So this is how to solve the question number 2. It's from the sample space. You see why the probability diagram is very important. It helps us to look at the sample space and find anything we want to get from it. Then the last question. The last question, in three tosses of a fake coin, what is the probability that a head appears at least twice? Now, this one, we are going to use another style. We are going to use the probability tree, because in probability table, we will only have 2 columns, the vertical column and the horizontal column. So if it becomes more than 2, we cannot use the probability table to create the sample space. We now use the probability tree. So to create the probability tree for 3 coins, number 3, to create the tree for three coins, the first one is head and tail. Then each of these legs we get another 2 legs. So this is the second coin, the second level. In the second level, we have head and tail. This one also gives us head and tail. This is for the second level of coin. Then for the third level of coin, each of this one also give us 2 legs. 2 legs. Okay, this one gives us 2 legs. This one gives us 2 legs. This one gives us 2 legs, and this one gives us 2 legs. So we have head and tail, head and tail, head and tail, head and tail. Okay, so what we are now going to do is to get to join the vents to see the sample space. To join it, join this one, this one, this one, and this one. That will now give us head, head, and head. Now we take this one from this side, we join it with this one, and join it with this one, and that will give us head, tail, tail. Then we also take this join it with this, join it with this, and come to this side, and that will give us head, tail, head. Now we join this to this and come through this way, and that will give us head, tail, head, tail, head, tail, tail, head, tail, tail. Then the fourth one, we join this to this and bind to this side, and so we have tail, head, head. We also start with this, go to this side and come to this side and come out, and so we have head, head, we have tail, tail, head, tail. We also join it with this and come to this side. We have tail, tail, head, and we join to this side and come here. We have tail, tail, tail. So in the sample space, we have how many? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 in the sample space, 8 events in the sample space. Now the question now is, what is the probability of getting, in 3 tosses of a fake coin, what is the probability that a head appears at least twice? That is, which one contains at least 2H? At least 2H. So we come to this side again. The sample space, which one contains at least 2 heads or 2H? So we count here, that is anyone from 2, 3, and above. We have here this one, this first one, head, head, head. It contains 3 heads, so it is among. The second one has only 1 head, so it is not among. The third one contains 2 heads, so it is among. The fourth one, 1 head, so it is not among. The fourth one contains 2 heads, 2H, it is among. The fifth one contains 1, it is not among. The sixth one contains 1H, it is not among. And the eighth one contains 1, does not contain head at all, so it is not among. First one, second one, third one, fourth one, fifth one, sixth one, seventh one, and eighth one. So we have 3 events that contains at least 2 heads, while the total number of events is 8. Therefore, the probability of getting at least 2 heads, 2H, is equal to 3/8. This is the answer. So this is how to solve this question. It's very, very simple. The first thing to do is to get your probability diagram, and once you get it, you can now begin to find anything they ask you to do from the probability diagram. That is either probability tree or probability table. If it involves more than two situations or events, you use probability tree. But if it is only two events that are involved, you use probability table. Thank you.